There we go. Okay, so quick review problem before you go into your breakout rooms. Let's say that we have f of x equals, by the way, you guys in groups last time had a problem that looked like this, and you were just asked to decompose it. Some of you used identities for that. We don't need to use identities. We would just rewrite this as sine of x squared, right? And then I would see this as, so I would say that this is of the form f of x is u squared, where u is sine of x. And then I would remember that to differentiate this, I would take that exponent down and then subtract 1. And then my chain rule piece here times du dx. Okay, so over here, let's get our du dx. Derivative with respect to x is cosine. So then we would put it all together, and I would have f prime of x equals 2 times, now remember, whatever was inside is still inside. It doesn't change. So 2 times sine of x, now times du dx. So that was a fairly straightforward one. I just wanted to mention it because it showed up in the group work last time. Let's do one more. Let's do f of x equals e to the 6x squared plus cosine x. Okay, so this is of the form f of x equals e to the u, where u is equal to 6x squared plus cosine of x. So we'll do our du dx and get 12x minus sine of x. Are we together? And here I have, well, let me change how I am indicating this. So this guy, f prime of x, is e to the u times du dx. And now I'm ready to plug everything in. Oops, some people are in the waiting room. So here we go. F prime of x equal e to the 6x squared plus cosine of x times du dx, which is 12x minus sine of x. So that's our quick review. You guys ready to go into your breakout rooms?
Let's do it.
Do you have questions for me? Do you remember what?
Yeah, real quick. So had that been a number, right? It's gonna be like e to the 6th power. It'll just be 0, right? We'll just convert it to 0.
Perfect.
Okay.
Yep, exactly. All right, let's see. Let me try the breakout rooms again because it didn't. Well, are you guys able to choose your rooms right now?
Yes, it's at the
Good.
bottom.
Okay, perfect. So go to your rooms, have fun. Okay, so if you need any extra help with that, let me know. I can reopen it if your group didn't get there. But I thought that, you know, we should have a little practice with it before we add to it, which is what we're doing today. Lots of discussion. Oh, good. So here we are in week 5. You guys are definitely warming up to this idea of working together, and I really appreciate that. And I hope you're recognizing the benefit of it. This is hard stuff. It's hard to do all by yourself. Gabriel, you guys didn't get all the way done. Okay. Remind me that.
No, I'm saying like we're a third done from the semester.
Oh, I know, isn't that? Wait, no.
Wait, actually?
There's
16.
16 total weeks.
I mean, about a third, like 5 out of 16. Like,
Is it the
But
end of
it's
last?
close enough, yeah.
We're like almost half, right? Okay, let's see. Let me make sure I have the right notes loaded here. Oh, I do, because we were looking at them earlier. So share screen. Further than we've ever been. Well, that is definitely a positive way to see it. Okay, here we go. So our notes for today, chapter 3, day 4. The My Lab Math chapter 3, day 4 is already posted. I'm sorry if you tried it because it was probably too hard, because there was stuff we hadn't covered yet. And by the way, Amber, it was chapter 3. Whoops, that's not what I want. Chapter 3, come on, pen. Technology is so cool when it works. Chapter 3, day 3, My Lab Math. Was it problem number 12?
Yes, you got it.
Okay, thank you. Problem number 12, after today. Sorry, that one snuck into the homework. You weren't really able to do number 12 based on what we did last class. So if you were doing the My Lab Math and you got to number 12, my apologies. It should have been in today's homework. Okay, so we are now going to learn 2 new rules called the product rule and the quotient rule. And what I want to remind you of, based on what you did today in groups on problem 1, is that if I have a function that is the sum or difference of 2 terms, I just take the derivative of each term separately. So the derivative of a difference is the difference of the derivatives. Right? So I could say that f prime of x is the derivative of sine of 3x minus the derivative of 2x plus 1 to the 4th. So you can break up sum and difference this way. So let's do that. This is a review problem. We're able to do this. So let's do some work off on the side. So for y equals sine of 3x, I'm going to see that as the form sine of u, where u is 3x. And then I'm going to find, and I know I switched notations. We've got to be comfortable with all these notations. So I'm just going to kind of throw them out there at different times. Over here, I'm using d dx, and over here, I'm using y prime. So, and there's no advantage of one over the other. Okay, you're just going to see them both in different days, different moments. So derivative of sine of u is cosine of u times du dx. What is our du dx?
3.
Perfect. So I get 3 cosine of u, which is 3x. Okay, good. So that goes right here. So my f prime of x equals, that first piece is the 3 cosine of 3x minus, let's do the next piece. Does anybody love colors as much as I do?
I use them sometimes, mostly graphs.
I'm telling you, it makes your notes so much clearer. It helps you when
Oh,
you're
God.
working a problem, you got like 8 different colors. Like everything just
I
makes
know.
sense.
I
It
want
really
more
helps.
colors. I need to find some.
Hey, I got
Oh.
a whole pack of like different
That's the way to
colors.
do it.
Are those the erasable ones?
No, unfortunately. I should get some erasable ones for that.
I think the brand that does the nice erasable ones is the Friction, but be warned that heat erases them. So I like left a set of graded papers in my car at one time.
Oh, no.
All the grading marks.
Fatal in
away.
Texas.
Oh, no.
That's depressing. Oh, my goodness.
I guess everyone got 100 that day.
They all got 100 exactly. So this is of the form u to the 4th, where u is 2x plus 1. If you don't show side work, that's fine. So y prime is 4u cubed times du dx. So we'll put it together and we get y prime equals 4 times 2x plus 1 cubed. What is our derivative of 2x plus 1?
That's 2.
Just a 2, perfect. So when I bring that in over here, maybe I'll put the 4 and the 2 together, and I have 8 times 2x plus 1 cubed. So there is my f prime of x.
Quick question.
Sure.
So when you're given an equation that's just something like y equals blah blah, is the correct notation just dy over dx, or can you
So-
do like f prime of x?
I'm glad you asked that. So y prime and f prime of x and dy dx and d dx of f of x and d dx of y. They're all the same thing.
Interesting.
Yeah, and the
So-
textbook in my math lab like to use every single one interchangeably and make everything more complicated.
Yeah, like
Just a warning.
I'm slowly starting to understand the notation. It's kind of cool because when I looked at it before, I was just like, holy crap, it's division, but it's not.
Yeah, no, it's not division. So like the D's don't cancel out. So what you need to think of these as is a very small change in y and a very small change in x as, let's say, that distance goes to 0, right? So we're talking about infinitesimally small changes in y's and x's.
All
Okay.
right.
So yes, we've got lots of different options for notation. I'll try to use plenty of them like my lab math does so that we get exposed to them. So now let's see, we found the derivative, check. Use it to write the equation of the line tangent to the function at x equals 0. So this right here is a function, right? That's our derivative function. And so now we're going to evaluate it. So evaluate f prime of x at x equals 0. And what will that give us?
It gives us 3 cosine of 0 minus 8 times 0 plus 1 cubed.
Perfect. And what object, how will that help us here? What does that represent?
What do you mean?
Slope of?
Oh, the slope of the tangent line.
Yes. At x equals 0. Good, Matthew, and we'll take the slop. Okay, f prime of 0. So 3 times cosine of 0 would be 3 times 1. And let me move this guy out of the way. And then minus 8 times 0 plus 1 cubed. So it looks like I have -5.
So that's the slope.
That's the slope at that point, right? The slope will change different points. So now to find the equation of the tangent line, I now have slope and I have x, but what else do I need?
You need b.
B, or we could just use a generic y in the point slope form.
Oh yeah, yeah.
So either one, but let's plug in this x equals 0 into our f of x. So our y, which is f of x, but we'll plug in 0. So I have sine of 0 minus 0 plus 1 to the 4th. So that's just -1. So now we're ready. We're going to put it all together. And we have y minus -1 equals -5 times x minus 0, which would be -5x minus 1. That is our tangent line at that point, right? Because tangent lines are different at different points if it's a nonlinear function.
It's really cool how this all just works together.
Yeah, good. And the nice thing is we're going to stick with this derivatives and tangent lines all the way through chapter 4. So we're just going to keep on building.
I thought you were gonna say through the rest of the course.
No, it's not that consistent. We have to do some new crazy stuff right before we say goodbye. We'll go backwards. We're going to do anti-differentiation.
Isn't that just like backwards derivatives?
Yep, backwards derivatives. We will be doing the sort of reverse engineering, exactly. So what we just did right there was taking the derivative of a sum or difference by differentiating each term. I am not doing Calc 2 in the spring. I'm not doing Calc 2, but I can help you when it comes time to picking, give you some ideas. All right, other arithmetic operations are more complicated. So times and divide, that's what we're focusing on today. Product rule. If you have, so look real closely, this is not composition, this is product. Okay, so just to rewrite this, this is f of x times g of x. This is a product. And how do you take the derivative of that? Well, dy dx is, you leave the first one alone, and you take the derivative of the second one. And then you have to be fair. You would leave the second one alone and take the derivative of the first. Yes, Anne Vance is great. And that is our product rule. It's funny because Anne and I actually went to high school together. We didn't really know each other very well in high school. And then when we got hired, we were office mates for a while. It's pretty funny.
Wow.
Yeah, small world. It is
Actually,
weird. You took her for pre-calc? Yeah, I really like
Are you a local? Like you were born here?
Yeah, but I left for 20 years and came back for the job. And then, so funny, we were hired like the same year, she and I were. And then we were office mates for a while at Rio Grande. It's pretty funny.
it's a maximum coincidence.
Yeah, exactly. Lots of overlap. I like her a lot. All right, so remember that addition and multiplication are both commutative. That means they can switch places. So this can be written lots of different ways. Some people will write f of x, g prime of x plus f prime of x, g of x, right? They just swapped those. Or maybe they'll swap those. It doesn't matter. You can write these in any order you want. But the point is you're differentiating one function each time. This time this one gets differentiated and the other one is left alone. The next time this one gets differentiated and the other one is left alone. And then of course you add them up. So not too bad. This rule is pretty simple. Let's practice it. We have to recognize that this is one of our functions, x cubed, and it's being multiplied by this other function, cotangent. So I'm going to write these out today in a lot of detail. You pick how much detail you want to write. I'm going to show that I'm leaving the first function alone, and I am differentiating the second function. And then I'm going to leave the second function alone. No, because question 1 in group work actually had a plus or a minus. So question 1 in the group work was like this. Yeah, thanks for asking that. But now that we have times, it works out a little differently. Second function times the derivative of the first function.
So real quick, I need a quick refresher. Why does it turn into f of x times g prime of x plus f prime of x times g of x instead
Oh.
of just like f prime of x times f g of x?
I heard you saying two of the same thing there at the end. You said, why is it f prime times g of x instead of f prime of x times g of x? So I must have heard you wrong. Tell me.
Oh, I swapped the order when I said the second one.
Oh,
Yeah,
gotcha. Okay.
yeah, I said f of x times g prime of x times f prime of x times g of x. Anyway, the question is, why does it not just become g prime of x times f prime of x?
So why is dy dx here not equal to f prime times g prime? Is that what you're asking?
Yeah, if it's a product rule. Well, if it's a product.
So you can go through the book, has maybe a full page of deriving this formula.
Oh, so right now it's just, it works.
Yeah, so we would have to say the limit as h approaches 0 of, and if it's f times g, we would have f of x plus h times g of x plus h minus f of x times g of x, all of that over h. And then it goes through trying to explain where this all comes from.
Okay, and so that ultimately becomes that.
I think probably at this point, what we should do is just take the rules as given. And later, when we've kind of worked with them for a while, it would be fun to go back and try to understand where they came from.
That's interesting. My last professor had always, whenever he introduced the concept, and this was pre-calc,
Mhm.
he would always show
Show
us
where it came from.
why it works.
Right.
Because he's
And
like,
I
if you see why it works, then you don't have to memorize it.
Sure. And I can see that I would do the same in pre-calc because each step is just a slight building on what you already knew. But if you guys glance in the book for the derivation of this, you'll see that it's not simple. So calculus is, since it's all a brand new topic, we're just going to kind of teach you some fundamentals of it. Exactly, Sonora. You can't really derive everything when you haven't learned all of the calculus yet. So for instance, last class, we learned the derivatives of the trig functions. And today, we are actually going to derive one of them. Where is it? Here. We're going to derive it. But we couldn't because we didn't have all the tools in hand. So we're going to use these for now because calculus is this new complicated concept. And later when we have more tools in our hands, maybe we can go back and derive some. You cannot just take the prime of f and the prime of g and multiply them. No, you have to follow the product rule. Sorry, you guys. I appreciate that you're all, questioning authority. Question authority in lots of ways, but not with the product rule.
So
all right,
do
you
it.
ready? So here we go. I don't need the chain rule for any of these pieces. They're all pretty straightforward. So let's just go ahead and do our derivatives. We have x cubed, derivative of cotangent. It just works.
Period.
Derivative of the co-functions always has a negative involved. Negative cosecant, cotangent, right? So this derivative is right here. Nope, I did it wrong. How about negative cosecant squared? Cosecant squared. Anybody catch my mistake yet? Or were you guys still like writing it down? Hopefully nobody noticed.
That is,
Haven't memorized the
I saw
trig
nothing.
stuff yet.
Oh man, good.
it's like the I'm thinking about,
Derivative of cotangent is negative cosecant squared. All right. Sorry about that. I almost had it wrong. Now let's keep going. We're going to leave cotangent alone. And then we're going to multiply by x cubed. And we get 3x squared. Says who? I love it. I was that student who got sent to the principal's office a lot for saying, but why? And then I figured out in college, okay, now the Ys, they like my why questions. They
I
don't
know,
send me
right?
away anymore. It's
It's really
awesome.
weird.
I know. So if this were a quiz or a test, Julie would be very happy with this answer. But if we need to simplify it for my lab math or to check in the back of the book, we should probably pull out maybe an x squared And then maybe I would not write the negative term first. So however you would want to simplify it, I think I might do 3 cotangent of x minus x cosecant squared x. So that is a little bit more simplified. But again, I am going to want you to stop here because I want to focus on your calculus mistakes, not your algebra mistakes for now. Okay, when we get into chapter 4, we're going to have to simplify these. So we'll wait until then.
Okay, that got me though real quick. Okay,
Sure.
where did the x cubed go then in that scenario?
So x squared times x would
Oh,
have
okay.
that x cubed. So see, this is what I mean. The algebra we could get so bogged down in. Especially now that we have the trig functions. There's all kinds of stuff we can do with the trig functions. Notation question, instead of d dx, can you do x cubed prime? You talking about right here, Sonora? So if you did x cubed prime like that, I would maybe stay away from that because I would almost read that as an exponent.
Okay. I was just curious. My last professor put brackets and then a prime.
Oh, for Calc 2 or for, because I was your Calc 3 professor.
For
You
Calc 1 and 2.
did that.
Mhm.
Interesting. I have never seen that before.
But if you prefer the DDX, I'll
No, if you do the bracket like that, yeah, if you do the bracket like that, that's fine. That's interesting. Maya likes this rule because although you're sure it'll get a lot worse, no, it's not too bad. The shortest of shorthand. Let's try one that's slightly worse. Oh no, that's it. That's all I'm doing for the product rule for right now. We're going to go on to the next rule, which is the quotient rule. So Ethan likes everything except the chain rule. So the way the book
chain
presents
rule.
this, so they go through all of this, the product rule, the quotient rule, derivatives of trig functions, logarithmic functions, and then right at the end of the chapter, they're like, just kidding. We have to put the chain rule in and go back through everything and redo it. So you guys are getting the pain over with early, okay? So you hate the chain rule now, but it's gonna settle. It'll settle. Just like when you start,
Wait until you see the quotient rule.
here it comes. All
Oh
right,
boy.
so recognize this as one function divided by another function, okay? That's what we've got here. So how do we take the derivative? We have y prime or dy dx, whichever you prefer, equals, now this time the order matters. Because I have a fraction, that's not y, because I have subtraction up here. And subtraction, of course, is not commutative. So I have the denominator first, leave it alone, times the derivative of the numerator minus the numerator times the derivative of the denominator. All of that divided by the denominator squared. Some people remember this sort of mnemonically as low times the derivative of the high, low d high, minus high times the derivative of the low divided by the low squared. Low d high minus high d low over low squared. Write it down a bunch of times, say it a bunch of times, say it to yourself while you're walking. Pretty crazy, but that actually helps you memorize things to have like some physical movement. Mnemonics do help, yeah.
When we're at a red light.
You're at a red light, exactly. Count all the cars in front of you. Low d high minus high d low. Yeah, just like that. All right.
Beautiful.
There's our rule. Let's apply it. I have a function that is the quotient of secant of 3x divided by e to the 5x. So before I start, because I know I'm going to need those functions derivatives, I'm going to do that off to the side. Charles used A and B. Interesting. So he had this as A over B, like that, Melody?
Yeah, and then it was B times A prime minus A times B prime over
I
B
like
squared.
that. I
Yeah.
like that. So there's an SI for another section. And if somebody reminds me through email, I will post both of those links for both of the classes. So maybe you guys can meet some people from other classes. Sonora, is that legal? Can you have people from other sections attending your SI?
Probably. I mean, since you're the same professor, it's probably the same.
I think it works out okay. King Philip,
I just do it because, sorry, go
I
ahead.
remember that one too. Well, say that again, Melody.
I was saying I just go to that one because unfortunately the timing for Sonora's SIs just goes right into my programming class. And then the Friday one is I'm almost always at work.
Right. Yeah, gotcha. It's also just good to meet new people. So I would, yeah, both of them are great. You guys
That
have
one's a
some
class
really
ahead
cool
too.
SIs.
So sometimes I get a sneak peek at what we're gonna do.
Interesting. Okay, cool. So someone remind me on email. So since we know that we're going to need these derivatives, let's go ahead and figure them out off here to the side. So I want to know what the derivative of secant of 3x is. So I'm going to think of this as secant of u, right? Where u is 3x. So derivative, good. So derivative of secant is secant times tangent times du dx, right? So let's plug stuff in. That du dx is just 3 here. So I'll put that 3 in the front. Secant of 3x, tangent of 3x. So now I have that derivative in hand. And how about e to the 5x? So the derivative of e to the u, where u is 5x, e to the u, du dx, perfect, Ethan, 5e to the 5x. And by the way, some really good discussion in office hours today. There are so many different ways to organize this work. And as you guys find your way to organize it, it's going to start making more sense to you. You and du dx. But as you get more and more nesting, sometimes trying to force a function name to each nested function gets more complicated. So eventually, and it'll be a while, you'll look at this and you'll say basic structure is e to the u. So I know I'm still going to have that guy. And then I take its derivative. There it is. So you're going to start being able to sort of mentally do the chain rule. You'll get there. Okay. All right, let's put this all together. Good job, Ethan. So here we go. Y prime equals the low, so e to the 5x, times d high, which is 3 secant of 3x, tangent of 3x, minus the high, which is, I can tell I'm going to have to squish this and slide over, minus high, which is secant of 3x, times d low, which is 5e to the 5x, over, and that was an awful line, over e to the 5x squared. So in case you're wondering where all that came from, let's write it out in detail here. This times derivative of that minus the top times the derivative of the bottom over the bottom squared. Okay, that's where all the pieces came from. I'm still obsessing about my line not being straight. Okay, if that were an answer for me, I would be happy, but you know that my lab math in the book won't stop there. How do I rewrite e to the 5x squared?
That's just e to the 10x.
Perfect, e to the 10x. So I see now that I have an e to the 5x here and here. I could factor that out.
You take out the 5 and
I'll leave the 5. I'm going to take out the e to the 5x because I don't have a 5 over here to take out. But I do have a secant of 3x here. And
oh, so you can
Yeah,
do you can do
square it.
15 minus, well, 15 secant blah blah minus 5 secant.
No, hold on just a second. I'm going to pull out the e to the 5x and the secant of 3x, okay? I pulled those out. Now let's see what's left. That first term, I'm left with 3 tangent 3x. And the second term, I'm just left with a 5. And then, of course, divided by e to the 10x.
Oh, okay.
Okay?
Yeah.
Now what? But wait, there's more. What else can we do?
Can you do anything with the e to the 5x and 10x?
Exactly, Matthew.
That'd be
We're
simple.
going to
Oh, okay.
reduce those. Good. So we're going to reduce these guys by subtracting their exponents. And of course, we end up down here because there are more of them, right? So finally, we're going to write our answer as y prime equals secant of 3x times 3 tangent. Oh man, I'm not going to make it. Hold on just a minute. I got to get some more room. 3 tangent of 3x minus 5. And all of that is over e to the 5x. I can see that that does clean up. I can see that there's a benefit to doing that. But
does look
I'm not
cleaner.
going to require it, okay? I won't require it. I will be perfectly happy with this answer right here. But of course, if you need to check your answer in the back or from my lab math, it's going to go to that. So, questions about the quotient rule part? I know the algebra is probably the more complicated part, but do you have questions on the quotient rule? Let me just shrink this down. Are we all good with the calculus part?
Looks good.
Okay, good. Next problem then. Your notes don't look like mine, do they? I think I have an old version of the notes here. My Google Drive has not been syncing correctly. I think you guys don't have this part, is that right?
No, I have that part.
No,
No, it's different wording. Sorry.
yeah, it's different wording. It's
Right,
use the
so-
product rule.
So
Oh,
B
sorry,
is
go
use the product rule, right?
Yeah, see, yeah,
Perfect.
down there.
All right, so we'll do that. So part A, take the derivative using the chain rule. I'm still trying to get this out of the way so you don't think it's that problem. Okay, using the chain rule. So this is of the form y equals u squared, where u equals 3x plus 1. Okay, so our dy dx, otherwise known as f prime of x, is 2 times u to the first times du dx, which is 2 times 3x plus 1 times du dx,
Which is just 3.
perfect. And if I could leave it like that, in fact, I will leave it like that. Now, what if we wanted to use the product rule?
I'm sorry to interrupt. That kind of confuses me. What's going on right now? Did you have two part Bs on yours?
I had a part that I'm not gonna do. I just took it out. It says expand out the
Is-
polynomial.
is
So
that the-
now,
Okay, but that's not on ours.
correct.
Oh, okay, all right, yeah, that's what got me. I was like, huh?
Wait, which part is not on yours? What's your part A say?
Take the derivative using the chain rule.
Okay, good. So now mine looks like yours.
Yeah.
So we're set. Thank you. Okay, cool. So part B, so I had modified these notes and I posted the modified version, but it didn't sync to my iPad. So my iPad has the old version. That's the confusion. Use the product rule to take the derivative. Well, I don't have a product. I just have 3x plus 1 squared. So I could rewrite it. So I could rewrite f of x equals 3x plus 1 times 3x plus 1. Now I have a product. And so now I can use the product rule. So you guys do that while I get the right version of the notes and let me know what you get.
That actually ends up being really easy because they're both the same. So the derivative and the base function is going to be the same.
Yeah,
It's just 3 times whatever the function was. I don't have the notes open.
3x plus 1.
Yeah, you just multiply them all. So you can multiply 3 times 3x plus 1 time. Well, no, you add them. It's 3 times 3x
Yeah, you're
plus 1
supposed to- yeah.
plus 3 times 3x plus 1.
Yep.
So you get 9x plus 3 plus 9x plus 3. You get 18x plus 6.
Wouldn't we just, for her purposes, just stop at 3x plus 1 times 3 plus 3x plus 1 times 3?
I just like to simplify. So
Oh, yeah, I
think
mean, that's
finished
fine.
it-
I was just
finished it off
wondering.
my head.
So the
So good.
cool thing is here, good job, you guys. The cool thing is to see how they're the same. So where am I? Here we go. Now my notes should look like yours. So when we did the chain rule earlier, let me just transcribe here. We had 2 times 3x plus 1 times 3. And what I just heard you guys do, and nice work, by the way, when we had f of x is 3x plus 1 times itself. You had f prime of x is the first times the derivative of the second plus the second times the derivative of the first. And I just want you to verify that you get the same answer. Right? So if I multiply these both out, which I've told you normally you don't have to do, but let's just do it here to verify. 3 times 2 is 6, distribute that, I get 18x plus 6. And here, 9x plus 3 and another 9x plus 3, and I get 18x plus 6. The whole point is to remind you that you have choices. Okay, sometimes it's easier to think of a problem using the chain rule, and sometimes it's easier with the product rule. And by the way, this problem that we worked out just a moment ago, you could have used a different form of this. You could have said, this is secant of 3x times e to the negative 5x, and then use the product rule. I have had students in the past who go to very great lengths to avoid the quotient rule, and they rewrite every quotient as a product. Most of the time it goes okay, but sometimes it can just really make the problem harder. So know both rules, and sometimes you may want to use the product rule instead of the quotient rule, and that's fine. Just recognize that your answer and the back of the book's answer might not be the same. If you ever want to check your answers, you go back to that set of notes. Whoops. Where is it? We are here, calculus, Tuesday, Thursday. I believe we're right here. If you ever want to know if your answer is the same as the back of the book and you don't feel like simplifying, you could graph it and then graph their answer. And if the graphs line up, you have the right answer. I mean, this one would be a pain because there'd be so much typing. But for some of the other ones, it actually might sometimes be quicker than doing all the algebra. Can I show you the process for finishing example 2 using the product rule? Well, certainly, let's do that. Product rule. So here we go. Y prime equals the first times the derivative of the second plus the second times the derivative of the first so that works. You could do a little bit of simplifying. You could say that that is e to the negative 5x secant of 3x times negative 5 plus 3 tangent of 3x. And remember, our other answer, I believe, was secant of 3x times negative 5 plus 3 tangent of 3x over e to the 5x, which is the same thing, right?
It's basically the same thing, except it's on one line instead of a fraction.
Yep, exactly. Sometimes it's going to be easier using the product rule, sometimes easier using the quotient rule. Don't get too used to it though. Try to make sure that you can do the quotient rule, because sometimes it's really necessary. But a lot of times you can rewrite it and do the product rule. Okay, important note, always consider algebra before calculus. We talked about this last time. Sometimes it will help. For example 4, I could use the quotient rule. I could also use the product rule, or I could do algebra first. What would it look like if I did algebra first?
Couldn't you remove couldn't you subtract 3 from the exponents?
So I would just have x to the 4th minus x to the 1st.
And then that's just,
so much easier to differentiate.
yeah, that's just 4x cubed minus 1.
Right? I know we forget our rules of exponents, you guys. I get it. Some of you probably wanted to put these together and call it x cubed. They're not like terms, so they don't get to go together. So we break this up into 2 fractions, both of which have an x cubed in the bottom. Subtract the exponents. Okay, so that problem, be on the lookout for problems like that in homework. They're going to throw them in there, I promise, things that could be simplified and are much easier. If I worked this with the quotient rule, it would look like, here we go, f prime of x is low d high minus high d low over the low squared. Fun.
Right.
Simplifying that. See what I mean?
Mm-hmm.
Let's stick with the algebra first, at least consider it. Okay. Example 5, let's start putting all this stuff together with what we learned last time with our trig functions and our chain rule and now the product rule. This one has just a little bit of everything. Derivative of 5e to the x squared cosine of pi x, and there is a product in between. Now,
I didn't
go
I
ahead.
didn't even know that was possible, an exponent to the exponent.
Anything is possible, Gabriel. We can just make it keep on going. All right. Let's see. I'm going to take these off to the side separately. So d dx of 5e to the x squared I'm going to see that as d dx of 5e to the u, where u equals x squared. So this equals 5e to the u, the derivative of that is 5e to the u times du dx, right? Are we all okay?
Yeah.
Okay, let's finish that off then. So that equals 5e to the x squared times derivative of x squared, which is 2x. So I have that one ready to use. Let's do the other one. D dx of cosine of u, where u is pi x. Derivative of cosine is negative sine of u times du dx. What is du dx here?
That's 1.
Close.
Wait, is it 0?
Pi.
Because
What would
yeah.
you say is the derivative of it if it was 3x?
Oh, we're multiplying. I'm smart.
If
It's
it was
3.
3x, you'd say it's 3. Exactly, Val. We have to
Just-
remember that pi is a number.
My brain is just like pi plus x.
Okay, so I think I'll just write this down. Negative sine of, wait, whoops, what's our u? Pi x times pi. So in fact, I'll rewrite that negative pi sine of pi x. Okay, I have my derivatives ready. So now let's find the derivative of the product. So I will write this step out because we're still just learning. It's the first function times the derivative of the second function plus the second function times the derivative of the first function. All right, so now let's plug things in. So my f prime of x is, leave that 5e to the x squared alone. And cosine of pi x, its derivative was negative.
Negative.
Good, pi sine of pi x, there it is. And then plus, leave the cosine of pi x alone. And we want the derivative of 5e to the x squared, sorry, and we found that earlier. I'm going to put those pieces together and just call it 10x e to the x squared. I do see one thing we could pull out, I guess 2 things. If we wanted to, we could pull out 5e to the x squared and we'd be left with negative pi sine of pi x plus 2x cosine of pi x. I believe that that's right. But I tend to make algebra mistakes too. So feel free to double check me. Okay, questions on the product rule or the quotient rule?
Yeah, I think that this is using colors here makes it a lot easier to try to like figure out where you can factor out of, where everything can blend in with each other, all that
I
kind of stuff.
agree.
So
Yeah, I agree. Find a good organizational manner that works for you. Gabriel, what's your question, comment?
Never mind, I looked at it and I figured it out.
Oh, excellent. Glad I could help. Guess what, you guys? It's time to talk trig. I hope you saw my email about the potential trig boot camp. I will spend a 1-hour time block giving you a whirlwind review of trig. The email is asking you to choose between 3 potential times. Whichever time gets the most votes is the one I'll do. Looks currently like the Tuesday is winning. After you see that trig shows up in tonight's homework, you may change your mind because you may want it sooner. But I'm going to distill it down because there was a lot of stuff that you learned in trig that was super fun, but not super relevant for calculus. Okay, so I'm going to try to distill it down to what you really need to move on with calculus using trig. It'll be recorded, yes. I'll definitely record it and post it. I see you guys fighting it out. Okay, recall double angle identities for sine and cosine. Well, let's see, sine of 2a is 2 sine A cosine A. Amber, go ahead.
I just had a question just on the when you want us to express our answer portion, like up in example 5, just like hypothetically, if we left the derivative of 5e to the x squared as the form that's circled right there, yes,
Mhm.
and we forgot to bring
Totally
the
fine.
forward, do we get points counted off for that, or?
No, that's why I keep telling you guys for
Okay.
this chapter, I do not need you to simplify. When
Okay.
you're checking the answer with the back of the book, though, it's going to simplify. I'm not positive if my lab math will take the unsimplified form. I kind of suspect it will, because the way that my lab math checks your answer is it actually plugs a number in to your answer and plugs a number into their answer. And if they evaluate to the same output, then they call it good. So I believe unless it's multiple choice, which I don't think they are, you can answer a non-simplified form in my lab math and it should be okay, but don't quote me on that because I didn't write it. For me, I'm happy with the non-simplified. In fact, I prefer it. On the new homework quiz, I say do not simplify because I don't want to have to find your algebra mistakes today. I'll find them in a couple weeks. All right, so there's sine of 2a, and then we have cosine of 2a, which is cosine squared minus sine squared. And yes, it has 2 other forms. I don't memorize them. If you told me right now I had to write them down, I would have to stop and derive it real quickly. I could do it in a minute, but I didn't memorize them. Your brain is only so big. So the way that you get to the other 2 forms is by remembering that sine squared plus cosine squared equals 1. You can rearrange that to substitute for this guy, or you can rearrange that to substitute for that guy. Okay?
We're coming back.
Yes, nice. Okay, we've got those in place in case we need them. Example 6, find all x coordinates in the interval including 0, not including 2 pi, for which the tangent line to this function is horizontal. My gosh, there's a lot going on here. X coordinates, so I know my answer is going to be x equals something. So I'm going to just remind myself that's where I'm headed. What does this mean if the tangent line is horizontal?
Means there's a change of change of 0.
Exactly. So if m is 0, that means f prime of x is 0. And then we're going to solve for x. Okay. So f prime of x, let's do it. F prime of x, this is not a product or a quotient, it's a difference. Derivative of cosine is negative sine. So I have negative 2 sine of x. The other piece, derivative of cosine is negative sine. And now this one has a chain rule piece. Derivative of, derivative of 2x equals
Now, in this problem, would it change into a positive sign? Right, because it's already, okay.
Good job. So plus 2 sine of 2x. Good. Well, how come she wrote those identities up there and didn't use them? I could have used this in place of that. I didn't want to, because then I would have had chain rule here and chain rule here. And trust me, it would get worse if you do it that way. So instead, I want to do the derivative. I want to wait and make the problem bigger only when I see that I have to. So far, I didn't have to. But they told me to set this equal to 0. Okay, so let's do that. -2 sine of x plus 2 sine of 2x equals 0. Well, I feel pretty clever that I can divide 2 away everywhere. And so I have negative sine x plus sine of 2x. That 2x is inside the sine function. Can you solve that as it stands?
Not easily.
What if I rewrote it? Sine of 2x equals sine of x. Does that help anybody? You want to divide both sides by sine and you could be left with 2x equals x and your answer is x equals 0? Wait, what? You wouldn't do that, right?
So this is where you break it up into the
This is where you break it up using an identity. All right, good. So here we go. Because these arguments are different, this equation cannot be solved as it stands. So I'm going to leave this piece alone and change this to 2 sine of x cosine of x.
I see what happens here. You add sine of x to the other side, you divide them both by 2
But don't
sine of.
ever divide by anything that has a variable.
Oh,
If you do, you're going to lose solutions. The safe alternative to division is the F word.
factor?
Yes.
Oh,
Factor.
okay.
Safe alternative to division. Factor out the sine of x. And you are left with -1 plus 2 cosine of x equals 0. And I now have 2 branches of solutions. This one did not get divided away. Good thing, because sine of x equals 0 has 2 solutions in that interval. X is by Sonora. You want to put in a plug for an SI session?
Come to SI. I have a Kahoot.
When is it?
A Kahoot. We're gonna get those derivative rules down, y'all.
Nice.
Sorry.
Have a good
Alrighty.
afternoon. All right, next piece over here. If I set that equal to 0, I get 2 cosine of x equals 1, cosine of x equals 1/2, and I get 2 answers out of that, pi over 3 and 5 pi over 3. If you don't remember those, come to the Trig Boot Camp. All right, we are almost done. Example 7. Now that we know the quotient rule, we can derive the derivative for tangent. So starting with using the results. So that means that I get to start with, or I can treat those as given. So given d dx of sine of x equals cosine of x, and d dx of cosine equals negative sine. Okay, so we're going to use those in order to derive the derivative for tangent. This is exciting. F of x equals tangent of x, which we remember is the quotient sine over cosine. So now we're going to use the quotient rule to take this derivative. So f prime of x is low, D high minus high, D low divided by low squared. All right, what happens here? Derivative of sine is cosine. So I have cosine times cosine, right?
Minus sine times negative sine.
Perfect. Over cosine squared.
Oh, that just equals 1 over
It
cosine squared.
does, yeah, because the minus and minus is a plus. Cosine squared plus sine squared equals 1.
And then you can simplify that to secant squared.
Isn't that fun?
Pretty cool. Oh, and that's why it just equals that. Okay.
That's why the derivative of tangent equals secant squared, and we could not have developed that last class. So this is why sometimes I'm just going to have to give you stuff and you're just going to have to believe me. And then later, if we have better tools, we can prove some things.
Well, I mean, I like that. I like that we were able to come around and prove that that's
Yeah.
why it worked.
Good.
That really
Megan?
solidifies the concept for me.
Good. Megan, was it the trig part that you wanted me to go over? So this, simplifying it, yeah. So this part is cosine squared. And this part is sine squared. All that is over cosine squared. But cosine squared plus sine squared, Pythagoras has taught us, is equal to 1. So that's where we got this 1 over cosine squared. Okay, did that help?
Honestly, the only thing that's stumping me though is how you distributed the negative and turned them both positive.
Gabriel, are you okay with it now that I have this written out?
I mean, yeah, I know that part, but like, how'd you distribute that? You know how it's minus sine
Yeah.
x over the derivative?
The derivative of cosine x is negative sine.
Right. Oh, and then if
Minus
you
the
had,
negative.
okay, got it.
All right, last page. We are doing a little bit of 3.6. The neat thing is that it's nothing new. We've already talked about how derivatives are representing velocity if the original function is position. We've already looked at graphs of derivatives and graphs of functions and tried to understand what they're telling us. So now we're just doing it again. Okay, so example 8, we have the position of a particle, that's this axis, moving with respect to time. When is the object moving in a positive direction? So when is the change in S positive?
When, do you want the intervals?
Mm-hmm.
When s is equal to, well, when t is less, well, from 0 to 1,
0 to 1,
0 to
And
1, and
then
3 to 4.
3 to 4. So when we're going up, the thing is moving in the positive direction. So we won't include endpoints because they're weird. They are the spots where the derivatives are 0. And 3 to 4, and it's going in the negative direction here and here. And so we have 1 to 3 and 4 to infinity. When the velocity is defined as the derivative of the position function, right? We've talked about that before. Let's assume that the velocity is 0 at time 0. So they're saying, okay, it's flat here. Where else is the velocity 0?
So 0 at 1, 3, and 4.
Good. So I have a horizontal tangent there, and there, and there. All right, good job. Anybody have questions so far? Okay. Then when is the, I'm going to skip D for just a second. When is the velocity positive? Velocity is positive in the same place that the object is moving in the positive direction, right? So that would be right through here. All of these slopes are positive. So I have 0, 1, and 3, 4. And then in here, the slopes are negative. Oh. I didn't ask that. I just asked where is the velocity positive. I'll put here velocity is negative on 1, 3, and 4 to infinity. So that's just sort of an extra. Okay. Now let's go back up. Part D, sketch the graph of the velocity function. I'm going to have to erase all my markings on the graph. So take a quick screenshot. 5, 4, 3, 2, 1. It's gone. Okay, we're going to try to draw the velocity function in. Let's use pink. I know the velocity is 0 here, 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 and here, right? Because we talked about that. And then I know that the velocity is positive from 0 to 1 and from 3 to 4. And I don't know exactly what shape this thing does, but I know that there are no more x-intercepts in here or t-intercepts. So I know that it just does something like that. And over here, it's going to do something like that also. Now let's look at the negative part. Right here, the slope is 0. Right here, it's maybe a -1. Right here, it's like a -2. And I think it's probably its steepest about right there. And then it gets less steep and less steep until it hits the 0 again. So that means that these y values are negative. And remember, the steepest was about here. So that means my lowest y value should be there. And then it's going to come back up like that. So this lowest value needs to correspond with the steepest part. And then after this 0, I see negative slopes forever. So this just goes down like that. So this is our velocity function. Move that note. Steepest. I don't think steepest is a word, but you get what I mean. Most steeper.
Most steeper.
All right, now where is the velocity increasing? Where is the velocity increasing?
It's from 0 to 0.5.
Right here. Good. And right here. So velocity increasing means that the velocity function is going uphill. 2.1-ish to maybe 3.5. Okay, perfect. So we'll answer that part 0 to maybe 0.5 and maybe 2.1, something like that. to maybe 3.5. Okay, so I had to graph the velocity function in order to see that. Later in the semester, we're going to learn a different way that we could have seen that just from the original position function. So finishing this up, this is the only new thing in section 3.6. Speed is the absolute value of the velocity. Like when you look at the speedometer in your car, it's never negative. Even if you're backtracking back towards home, it doesn't say you're going negative 30 miles an hour, right? It's always absolute value. It does not have direction. So that means in order to find the graph of the speed function, I would take the absolute value of my velocity function. This is going to be pretty cool. If you did not do this in pre-calc, welcome to an absolute value of a graph. I'm trying to get that off. There we go. Anytime that the graph is above the axis, it stays the same. But anytime the graph is below the x-axis or the input axis, it gets reflected up. That should have been a reflection, so let's try that again. Should be like about like that. And then this piece, instead of curving down, curves up. So this is the speed function of t. Now, where is the speed 0? Well, it has the same zeros as the velocity. Yeah, I know, I love taking absolute value of a graph. It's pretty cool. The zeros did not change, but the intervals of increase, decrease, positive, negative, all that changed. Speed is increasing everywhere that it's going uphill. So that will be on the intervals 0 to 0.5. And 1 to 2.1, I think is what we called that before. And then 3 to 3.5. And then 4 to infinity. So I guess
Cool.
sometimes I use U and sometimes I use a comma. I don't care which one you use. All right, you guys, that is it for the week.
Oh, so you can use a comma instead of you then.
It's fine.
Okay, because that confused me on my lab math. They only take commas, and I was like,
Oh,
what is
gotcha.
that? Yeah. Okay.
The important one that you can never get around is if you ever have an intersection, you can't write anything different from that. Yeah, the upside down U is intersect, and that you can't replace with a comma. So let me explain to you what's going on. You guys have my lab math week 3, day 3, that was for today. And the day 4 that you now can do because it's product and quotient rule. But in case that's not enough, I will post in Blackboard under this week, or this unit, I guess. I'll just post it right at the top under unit 2. I'll post some extra practice. Oh, there's also extra algebra fun in my lab math because some of you need some algebra fun. But I have created some extra problems because, like I said, the way that the book covers this material, they waited to do the chain rule till the end. And I want you to work it all the way through. So I posted some extra problems with answers included, or I will post those in Blackboard. So feel free to do those. You also will get the homework quiz, should be open any minute now, the new one. So plenty to do. Fill out the form for when you went the Trig Boot Camp. If you can't make it, that's fine, I'll record it. Any other questions or comments from you guys?
We're all set. For the trig, do we need to know? Well, actually, no. I think. Never mind. I'll just review the trig